Hello, and welcome to the MuscleGloss online training class. This course contains 5 chapters that will be delivered in 4 different presentations. This class will prepare you for being an authorized MuscleGloss installer. You'll learn everything you need to know about basic epoxy installation, plus a few advanced techniques you can use on the job. At the end of the course, there will be a test for you to see how well you did. So, let's get started with Chapter 1, Overview and Safety. Here's what we'll be covering in Chapter 1, Professional Installers. In this section, we'll give you an overview of what is expected from professional epoxy installers. A little bit about epoxy is a basic look at what epoxy is, what epoxies are used for, and in what industries. Conditions and cure rates. This is one of the most important things about installing epoxy flooring, and you will hear it referenced a number of times throughout the course. Safety. Always important. No one is in business to get injured. In this section, we'll cover safety equipment and handling procedures to ensure a safe installation. Characteristics and skills of a professional installer. As a professional installer, you will understand what epoxy is, what it does, and how it behaves. Have an understanding of the industry. Know what types of jobs to expect. Understand what surfaces epoxy can be applied to and what the difference in applications will be. You will be able to estimate jobs for customers, prepare surfaces for installation, perform basic cleanup tasks, install epoxy while utilizing proper safety and handling techniques. Understand how color of the epoxy affects coverage, understand how temperature and humidity affect cure time, be exposed to advanced application techniques, and create custom designs and patterns. An epoxy is any adhesive, plastic, paint, or other material made from a class of synthetic polymers containing epoxide groups. All epoxies begin as a liquid and chemically change into a solid. They are mechanically strong, resist degrading, and are highly adhesive. Epoxy is made from 2 components, a resin and a hardener. The resin is usually light, clear-colored, or pigmented, and nearly odor-free. The hardener is usually amber in color and slightly darker than a clear epoxy. It has a slight odor. When the 2 components are mixed, they will chemically bond and form a strong plastic material. Epoxy has a wide range of applications, including metal coatings, electronics and electrical components, high-tension electrical insulators, fiber-reinforced plastic materials, and structural adhesives and flooring. The word epoxy is derived from 2 Greek prefixes, epi, which means upon, and oxy, which means sharp and acidic. Epoxy has been around for over 100 years. Russian chemists began synthesizing epoxy compounds in the early 1900s. In the United States, epoxy was first synthesized by Dr. S.O. Greenlee and his Swiss colleague Dr. Pierre Castan. Dr. Greenlee and Dr. Castan are considered the fathers of American epoxy. Initially, epoxy was used in the marine and industrial industries. During the 1950s, its use expanded to include woodwork, building construction, and aerospace. Today, epoxy has emerged as a residential material. Homeowners love epoxy flooring because it is long-lasting, easy to clean, and practically scratch-proof. There are numerous uses for epoxy, ranging from coatings, adhesives, and electrical insulation to composite materials used in carbon fiber and fiberglass reinforcements. Epoxies can be produced with a broad range of properties and provide excellent adhesion, resistance to chemicals and heat, and electrical insulation. 2-part epoxy coatings were developed for heavy-duty service on metal substrates. These systems dry quickly to provide a tough, protective coating with excellent hardness. Their low volatility and easy water cleanup make them useful for factory cast iron, cast steel, and cast aluminum applications. 2-part epoxies are used in industrial and automotive applications because they are more heat resistant than latex-based and alkyd-based paints. Polyester epoxies are used as powder coatings for washers, dryers, and other large home electronics. These epoxies are extensively used for corrosion protection on steel pipes and fittings used in the oil and gas industry. They are also widely used as primers to improve the adhesion of paints on metal surfaces where corrosion resistance is important. Metal cans and containers are often coated with epoxy to prevent rusting, especially for foods that are acidic, such as tomatoes. 100% solids is a commercial-grade, quality epoxy. This type of epoxy does not shrink after application. Solvent-free epoxies, 100% solids, have no strong fumes and there is no thickness loss due to evaporation. 100% solids is the most durable epoxy system available today. Under normal circumstances, a properly maintained floor should have a life expectancy of 15 to 20 years. Epoxy adhesives are also known as structural adhesives or engineering adhesives. These epoxies are used in the construction of aircraft, automobiles, bicycles, boats, and other applications where high-strength bonds are needed. They can also be used as adhesives for wood, metal, glass, stone, and some plastics. They can be made flexible or rigid, transparent or opaque, or fast or slow setting. Epoxy adhesives are more heat and chemical resistant than other adhesives. In general, epoxies cured with heat will be more resistant to heat and chemicals than epoxies cured at room temperature. Epoxies are used in industrial tooling applications to produce molds, master molds, and other industrial production aids. Epoxy replaces metal, wood, and other materials that have traditionally been used to make these tools. Using epoxy generally improves efficiency, shortens the lead time for, and lowers the overall cost of many industrial processes. Epoxies are more expensive than other types of resins, but are stronger and more resistant to heat. Epoxies are used in the electronics industry in motors, generators, transformers, switchgear, bushings, and insulators. They are excellent electrical insulators and protect electrical components from dust, moisture, and short-circuiting. Epoxies are primarily used to make printed circuit boards and to overmold integrated circuits, transistors, and hybrid circuits. In the aerospace industry, epoxy is used as a structural matrix material that is then reinforced by fiber. It is also used as structural glue. Epoxy is used as a coating for metal containers to prevent rust and taste degradation. Epoxy mixed with pigment can be used as a painting medium by pouring layers on top of each other to form a complete picture. Epoxy coatings are often used as a primer to enhance the adhesion of paints that are applied as a final coating to hulls and decks. Epoxies are also used to protect the internal surface of hulls. Epoxies are highly adhesive and form a secure bond with both new and old concrete flooring surfaces. Epoxy is mechanically and chemically resistant and is used in commercial, industrial, and residential settings. Epoxy flooring is widely used in garages, basements, laundry rooms, showrooms, warehouses, schools, hospitals, industrial kitchens, shop floors, and on sidewalks and pool decks. Usually epoxy is used over concrete. Remember, though, that it can bond with just about any surface with the right preparation. Several types of epoxy floorings are available on the market. One-part solvent-based epoxies are not much different than paint. Water-based two-part epoxies available at various stores such as Home Depot. 100% solids epoxies like MuscleGloss are the longest lasting and most durable option available. Unlike water-based epoxies, 100% solids epoxies do not lose any thickness during the curing process. Temperature and humidity affect the cure rate of MuscleGloss 100% solids epoxy. However, working time, the time you have to apply the epoxy before it begins to cure, will be affected. Standard work time is 30 minutes. The colder the air temperature and lower the humidity, the slower MuscleGloss will cure. The warmer the air temperature and higher the humidity, the faster MuscleGloss will cure. This means you will have less work time than normal when either temperature or humidity is high. Depending on the nature of a project you have, MuscleGloss can alter the cure rate to account for conditions and adjust the work time of the epoxy. We can also give you the option to apply epoxy to walls. Ideal install temperatures for epoxy are between 64 and 74 degrees Fahrenheit. Ideal humidity levels are under 44%. Temperatures and humidity outside these ideal conditions will cause the epoxy to cure at a faster or slower rate. If you will be storing MuscleGloss or any epoxy for a period of time, ensure the product container is tightly sealed and kept at room temperature. Avoid exposing epoxy to extreme heat or cold and widely changing room temperatures. Whenever you have any safety concerns or are unsure about anything, please refer to the MSDS and the HMIS and NFPA symbols enclosed with each MuscleGloss product. Exposure to epoxy can cause skin inflammation ranging from mild irritation to severe allergic rashes, as well as eye, nose, and throat irritation and asthma. A main safety concern for installers is preventing the development of skin sensitization over time. Some people become allergic to epoxy after repeated exposure. The amount of exposure that causes sensitization varies from person to person. A person can develop an immediate allergy to epoxy, However, most people never become sensitive to the product. The best way to prevent the development of a sensitivity is to limit your exposure to epoxy as best you can while you are working with it. Using protective clothing will limit your exposure to epoxy. Gloves. Gloves are one of the most important ways to protect your skin. Glove manufacturers produce gloves to protect workers from specific chemicals. Gloves are rated by permeation and degradation measurements. Permeation measures how quickly a chemical travels through or permeates a glove. Degradation measures how quickly a chemical breaks down or degrades a glove. When working with epoxy, never use latex gloves, cotton gloves, barrier creams. Latex and cotton gloves absorb epoxy and will not provide you with adequate protection. Epoxy may break the seal of barrier creams. Additionally, reapplying barrier cream after working with epoxy may seal the epoxy to your skin. You may use cotton gloves or barrier cream underneath your gloves as an added protection. However, remember, you should never rely on them as your only source of protection. Gloves that are recommended for working with epoxy: vinyl, butyl rubber, nitrile. Make sure your gloves fit snugly. Loose gloves can let epoxy in. You can either use disposable or reusable gloves. Using disposable gloves may be easier for you. You will simply need to discard the gloves at the end of each job or at the end of the day. If you use reusable gloves, you will need to clean them daily. Wash the outside of your gloves before removing them. Watch for pinholes that could let in contaminated water. Remove your gloves and handle them by the insides only. Try not to touch the outside of your gloves. Store your gloves in a plastic bag away from tools and materials in a cool, dark, and dry place. Protect your eyes from epoxy by wearing chemical goggles that have side shields. It is recommended you wear goggles when mixing epoxy, sanding epoxy, or whenever a risk of getting epoxy in the eyes is present. Respirators. MuscleGloss 100% solids epoxy contains no VOCs and is safe to apply in enclosed areas without taking any respiratory precautions. When sanding epoxy, we recommend you wear either a face mask at the very least or a respirator. MuscleGloss UV Top Coat is the only MuscleGloss product that contains VOCs. When applying this product, you will either need to ensure the area is adequately ventilated or wear a respirator. Depending on the project, you may be able to get adequate ventilation simply by opening windows and doors and using commercial fans to increase airflow. If you are not able to ensure adequate ventilation, wear a respirator. Even though MuscleGloss epoxy is safe to apply without any added respiratory protection, it is a good idea to inquire about any hazards present in the work area. Dust can be a nuisance on the job site, especially when you're sanding epoxy. We recommend using a wet vacuum to reduce dust on the site. This works best. However, any type of vacuum will help you reduce dust and debris while you're working. A dustless floor sander is another method for reducing respiratory irritants. It's essential you remove epoxy from your skin by thoroughly washing with soap and warm water. Be sure to wash your hands and other exposed body parts before eating, after you've removed your gloves, and at the end of the workday. We encourage you change out of your work clothes before leaving work. This will keep epoxy from spreading to your car or truck. If you cannot leave your work clothes on the job, you should take them home in a separate sealed container. A plastic trash bag works well for storing used work clothes. MSDS stands for Material Safety Data Sheet. These documents provide needed information and procedures for handling and working with specific products or chemicals. Generally, an MSDS will outline the physical and chemical properties of a product, describe potential hazards, identify the manufacturer or manufacturers, and give emergency phone numbers and procedures. Refer to MSDSs when you are unsure of safe handling procedures or need emergency information. When in doubt, ask. All hazardous products are required by law to include enclosed MSDSs. HMIS stands for Hazardous Materials Identification System. HMIS was created so workers who work with or near hazardous materials could quickly determine the nature of the hazard and the specific precautions they should take. The system ranks the severity of hazardous materials in 3 categories and states the optimal configuration of safety equipment for working with that material. HMIS uses OSHA criterion to determine ranking. The blue section conveys the health risks associated with the material in a ranking from 0 to 4. 0 means there is no significant risk to health, while 4 means life-threatening or that major and/or permanent damage may result from single or repeated overexposure. The red section conveys the flammability of the material in a 0 to 4 ranking. 0 means the material will not burn. 4 means the material is a flammable gas or a very volatile flammable liquid with a flash point below 73 degrees Fahrenheit and a boiling point above 100 degrees Fahrenheit. The material may ignite spontaneously with air. Yellow conveys the physical hazard of the material in a ranking from 0 to 4. 0 means the material is normally stable even under fire conditions and is non-explosive. 4 means the material is readily capable of explosive water reaction, detonation, or explosive decomposition, polymerization, or self-reaction at normal temperature and pressure. The white area of the HMIS symbol indicates what personal protective equipment should be used when working with the material. NFPA stands for the National Fire Protection Association. This label was designed to warn firefighters and other emergency responders of the hazards they would be exposed to in a fire or chemical spill situation. NFPA labels are easy to interpret and can be very useful during an emergency. The label is diamond-shaped and separated into 4 color-coded quadrants. The red diamond at the top of the NFPA label conveys the flammability hazard level of the material in a number between 0 and 4. 0 means the material will not burn. 4 means the material is highly flammable and will burn and vaporize easily and quickly at normal room temperature and pressure. The yellow diamond on the right side of the label conveys the chemical reactivity or instability of the material in a number between 0 and 4. 0 means the material is stable even under conditions of high temperature and pressure. 4 means the material is highly unstable and prone to explosive reactions or decompositions even under normal conditions. The blue diamond on the left side of the label indicates the health risks associated with the material in numbers between 0 and 4. 0 indicates that the material presents no special risks under the high temperatures and pressures of a fire. 4 indicates the material poses a deadly threat to human life if released. Okay, let's check what we have covered in Chapter 1. Get your pencils and paper out so you can write down your answers for your first self-quiz. Question 1. What is epoxy? Number 2. Name 3 common applications for epoxy. Question 3. What is the ideal temperature range for installing epoxy? 4. Why is temperature and humidity important when installing epoxy? Question 5. What should you avoid when storing epoxy? 6. Name 1 type of glove that will provide good protection while working with epoxy. Number 7. When should you wear a respirator? 8. What is HMIS? Question 9. What does NFPA stand for? And finally, what does 100% solids mean? Congratulations on completing Chapter 1. Feel free to review any areas that you may have had difficulty with. We'll see you back here for Chapter 2.